guys, welcome to lesson 3, part 2 of unit 6. And we are just going to kind of hit some different things that we didn't in the first part. So the first thing that I want you to notice is these are going to flip-flop back and forth from radians to degrees. So if it's from like 0 to 360, we're going to be dealing with degrees. But the way this is going to be in radians. So just kind of keep that in mind. We'll come back to that. Okay, so the first thing that's popping out to me is that these are going to be like the sum and difference identities. So go ahead and get out your formula sheet and go ahead and apply what we have here. Okay, so there's a lot going on here, and you might be looking at these and want to go ahead and switch them out, and that's totally okay. You can do that. What I like to do first is go ahead and like simplify or like get rid of what I can get rid of. So like right here, we have that, and here we have the negative version. So those are going to cancel each other out. And then notice we have, these are the same. So I'm going to say 2 sine of x cosine of pi over 4 equals -1. So now I wait to here and say, okay, well, that is going to be square root of 2 over 2. So think about it, that's 45 degrees. Cosine 45 degrees is square root of 2 over 2. And then I have 2 sine of x. Okay, so then I have these two going on. So we're just multiplying everything together. So I'm going to combine the 2 and the 2 times square root of 2 over 2. So those cancel out. And I'm left with the sine of x times square root of 2 equals -1. So this is very like algebraic. So we are going to divide by the square root of 2. And I get, these cancel. So I get the sine of x equals -1 over the square root of 2. Or if you rationalize it, negative square root of 2 over 2. So now we are going to multiply both sides by the inverse because I've got to get the x by itself. So in order to do that, I'm going to multiply both sides by the inverse sign. Those are going to cancel out, and that's going to be x. Okay, so this is what I want you to think of. Sine inverse of, and think about, okay, well, that is a 45-degree reference angle, and sine is negative here and here. So I'm going to ask myself, okay, well, and we can think degrees at this point, doesn't matter. If this is 45 degrees, what's my actual angle there? And so that's going to be 225. And if this is 45 degrees, what's my actual angle here? And that's going to be 315. Okay, so 225 in radians, that's going to be 5 pi over 4. And 315 in radians is going to be 7 pi over 4. You have your like little unit circle sheet you're more than welcome to use. Let's say like you don't have it. What I always do, just like a quick, easy thing to do on your computer or on your calculator, is just take 225 divided by 180 and get a simplified fraction. That's going to equal 5/4. And same thing, 315 divided by 180, get a simplified fraction, 7/4, and we just add that pi in. So those are your two answers. Again, once you get your answers, look up here and make sure it's in the right form. And it is, it's in radian form. And that is it. So we're going to hit like just some different things here. So on this one, this is a little bit different because of this cosine, this double angle formula. And so here's the thing, cosine is a booger because it has 3 different types of identities that you can use. So I'm going to like think about when I'm picking out the identity, what's going to help me the most. So there's not like, you know, like in this case, you use this one. It's just what helps you the most. And so I purposely picked this identity because this is what I thought. That would put everything in terms of sine, and then maybe I can do something with it. So I'm going to just substitute that in. I'm going to say sine of theta plus 1 minus 2 sine squared theta equals 0. And then I think I'm going to move my terms around and factor it. So I'm going to make this positive. So think about like moving everything over here, if you will. So I have 2 sine squared theta minus sine of theta minus 1 equals 0. And in my brain, I'm not thinking that. I'm thinking 2x squared minus x minus 1 equals 0. And so I know that if I factor that, I'm going to get minus 2x plus 1 is negative 1x. So I like that. So now I'm just going to substitute back in the sine. So I'm going to say 2 sine of x. Oh, I changed this theta, sorry. 2 sine of theta plus 1, and then sine of theta minus 1 equals 0. So in algebra, the zero product property says if I set this equal to 0, the whole thing will equal 0, so it'll make it true. And if I set this equal to 0, the whole thing will be 0, and that'll make it true. So what we're going to do is we are going to just focus on each one at a time and set them equal to 0. So again, I'm going to go through the algebra. So I'm going to like subtract 1 and divide by 2. So I get the sine of theta equals negative 1/2. And so again, I want to get theta by itself. So I'm going to do sine inverse. And I get theta equals, now, so I want the sine inverse. I'm looking for the angle measure that will give me 1/2. So that's going to be a 30-degree reference angle. And the other thing that's jumping out at me is that it's negative. So where is sine negative? So just like another one, it's negative in quadrant 3 and quadrant 4. So if I have a 30-degree reference angle there, it's going to be 210. If I have a 30-degree reference angle there, it's going to be 330. So I didn't even look and see. So let's go up here, which form it's in. So it's in the degree form. So that is all I need to do. I don't need to transfer it to radians. So theta equals 210 and theta equals 330. Guys, if you are not sure of what you, like if you did it correctly, you should be able to type this in either here, or if you want to go up even better, if you want to go up to your original equation. So if you type this in your calculator, make sure your calculator's in the right mode. And so you could say 2 times 210, or you could say, oh, that 420. Either way, you're going to get the same thing, and it should equal 0. So like if you're not sure about your work along the way, you should be able to plug in your values. Same thing with 330. You should be able to plug those in and get the correct answer. Okay, so those are my 2 on that end. Go ahead and move that 1 over. And so this one, what's jumping out at me is it's a quadrantal angle. So I know that my y value is 1. So that is the only place that it occurs. So it occurs at 90 degrees. So my theta is 90 degrees. Okay, so let's go to this one. This one is a little bit different because I'm going to set you up for failure. So I'm going to show you what we have been doing. So I'm going to divide by 6, and I get sine of 2 theta equals 1/2. And then I'm going to use my identities. And so I'm going to change this into 2 sine of theta cosine of theta. Divide by 2. And I have sine of theta cosine of theta equals 1/4. This is a dead end. I can't go anywhere with this. So I'm kind of stuck. So I'm going to show you another way to do this. So the way that I'm going to teach you to do this is we are going to keep this as it is. So if you'll notice that my domain over here is just a regular theta. So the first thing I'm going to do is I'm going to multiply everything through by 2 so that I have 2 theta on the inside. So instead of going from 0 to 2 pi, sorry, I said that wrong. instead of going like 1 time around the circle, I'm actually going to go 2 times around the circle. Instead of like 2 pi, I'm going to have 4 pi. Okay, so let me show you how to do this. So we're going to go back here to this step. So I'm going to say the sine 2 theta equals 1/2. And I'm just going to go straight from here and find the sine inverse. So these cancel out, and I get 2 theta equals, okay, so sine inverse of 1/2, again, I have a 30-degree reference angle, but unfortunately, we're dealing with radians. So instead of saying 30 degrees, I'm going to say pi over 6. So it's positive in quadrant 1 and in quadrant 4. So I have pi over 6. And then I also have, let's see, in quadrant 2, I have 5 pi over 6. So let me show you. So here and here. So this is 30 degrees, this is 30 degrees. So normally we would say 30 and 150, but because we're dealing with radians, I'm going to say pi over 6 and 5 pi over 6. Okay, now this is going to hurt your head a little bit, but now we're going 2 times around the circle. So I'm going to think about, if I were thinking about it in terms of degrees, I would add 360 degrees to it. And so in that case, I would get like 390 and 510. So this is like kind of my cheat. So I'll take 390 and I'll divide that by 180 and I'll get my radians. So that's going to be 13 pi over 6. I'll do the same thing to 510 and I'm going to get 17 pi over 6. So these are my 4 radian measures. So I have 2 pi is equal to all of these. But I'm going to have to get it down to, I keep saying pi, I'm so sorry. 2 theta equals all those. So I have to get it down to theta. So I'm going to divide everything through by 2. So my actual radian answers are pi over 12. So let's go right there. 5 pi over 12, right there. 13 pi over 12 and 17 pi over 12. And these are my 4 answers. I think over this process here, I want you to go ahead and set it up. Just remember that when you take the square root, you're going to have both the positive and negative of your answer here. So this is going to be all 4 quadrants, positive, positive, negative, negative. So see what you can do there. Okay, so I'm just showing it in terms of degrees. I feel like that's what your comfort level is. So tangent is square root of 3 over 3. And we have a 30-degree reference angle. So what I did is I grabbed all the reference angles that were 30 around the unit circle. And then I added 360 to it because remember, we're going 2 times around the unit circle. So that's where these guys are coming from. And my final answer needs to be in radians. So I'm going to turn all of these into radians here in just a second. So let me go do that real quick. Okay, so don't forget, I'm going to draw your attention right here. This is equal to 2x. And so what we did, I didn't show my work here. We found the tangent inverse of that to get these angle measures. Okay, so we're left with 2x. So in order to get x by itself, I'm going to divide all these by 2. So my final answer for x is pi over 12, 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12. All of these are our answers.